All right, ACT warm-up number 8. Here goes something. Question 1, solve the following involving rational numbers. 7/16 minus 2 3/4. 7/16 minus 2 3/4. We're going to go through and do this in the calculator. So 7 divided by 16, and then 2 3/4 is 2.75, so 2.75. So you can do 7/16 minus 0.4373, or 0.4375 minus 0.75. So negative 0.3125. Then I'm just going to convert that to a fraction, and that's going to be negative 5/16. So that's going to be a calculator thing, and that's going to be negative 5/16. All right, 34.672 divided by negative 4.402. So 34.672 divided by negative 4.402. Whoa. We're going to leave that as a decimal, so that's going to be negative 7.87641. I'm going to round that. So I guess maybe round that 19 to 2. All right, 12 minus negative 5 minus 3 minus negative 1. Order of operations matters, so if we're doing this without a calculator, you would do the 3 minus negative 1 first, which is 3 plus 1. So that's 4. So 12 minus negative 5 minus 4. So 12 plus 5 minus 4. 17 minus 4, 13. We can check that in the calculator if we'd like. That would be 12 minus parentheses negative 5 minus parentheses 3 minus parentheses negative 1. Close it up, and you do get 13. All right, question number 2. Let me clear this stuff off. A bricklayer is building a brick rectangular post to anchor a mailbox. The post is 3 feet tall, 2 feet deep, and 2 feet wide. Each brick is 3 inches by 6 inches by 3 inches. How many bricks does he need? Well, remember 12 inches is 1 foot. So what I want to first do is make this into feet. 3 feet tall is 3 times 12. That's 36. 2 feet deep, that's 24. And then 2 feet wide is also 24. So 24 inches, 36 inches, 24 inches. Each brick is 3 inches by 6 inches by 3 inches. How many bricks does he need? We got to kind of draw this out, don't we? So we got, let's see, 3 feet tall, 36 inches, 2 feet deep, and 2 feet wide. So let's say this is basically a square. 24 inches by 24 inches by 36 inches. And we want to fit how many bricks? So 3 inches, 6 inches, 3 inches. So if each brick is 6 inches, I could do this, let's see, 3 inches by 6 inches by 3 inches. So if I divide this by 3, I get 8. Well, let's see, 3 inches by 6. What I'm going to do is I'm going to make these bricks go tall. So I'm going to have 6 bricks go, if it's 6 inches, 36 divided by 6. And then each of those is going to be 3 inches wide. And I have to fit 8 of those across because 3 times 8 is 24. So let's just take a look at one layer here. And that's 2 feet, so it's going to be 8 bricks there. So we have pardon my drawing. This is going to be 8 bricks by 8 bricks. And then this is going to be 6 bricks, if I do this correctly. So 6, 6, 6, 6, 6, 6, 6 times 6 is 36. 8 times 3 is 24. 8 times 3 is 24. So 6, 8, and 8. That's how many bricks there are going to be. 6 times 8 times 8. And 384 bricks. All right, the Wright brothers flyer had 484-inch wingspan. Carla bought a model of the plane with a scale factor of 1/40th. What's the model's wingspan? So 384 inches is 484 inches is the actual. If the scale model is 1/40th, we're going to multiply that by 1/40th or divide by 40. So that's going to be 484 multiplied by 1 divided by 40. So that model's wingspan is going to be 12.1 inches. All right, that was question number 2. Get those down and let's move on to number 3, and we'll clear this off. What would the dimensions of a photograph be that is similar be of a photograph that is similar to a photograph that measures 8 by 10? Write a set dimensions that would not be similar. Okay. Well, similar means proportionally the same. So if it was, see, 8 by 10, if you had one that was 4 by 5, that would be similar because each of those are half. Or you could have one that is 16 by 20. Right? Those are all similar because they have the same, proportions to them. So similar. So something that would not be similar, for instance, might be maybe 8 by 12. Because if it's got the same width here, but it's a little taller, that's not proportionally the same. Or you could have 4 by 6. Or anything basically that one dimension is not 8/10 of the other. So, you could pick other ones, but here's a couple examples that are not similar. Okay, goal 4. What are the mean, median, and mode and range of the shoe sizes of the 7th graders? So for the shoe sizes, so we have 6, size 6, 9 of them. So let's kind of think about this here. We have 9 6s, 10 7s, 12 8s, and 3 9s. So overall, I have 9 plus 10 plus 12 plus 3. How many is that? 34. So I have 34 altogether. So I have a 9 times 6, and I have 7 times 10. I have 8 times 12, and 9 times 3. So the combined numbers here add to 247. So if I do 247 divided by the total number there are, the mean shoe size is going to be about 7.26. So the mean is, let me just kind of recap, it's going to be 6 times 9 plus 7 times 10 plus 8 times 12 plus 9 times 3, and we're going to divide that by 34 total students, and that's going to be 7.26. That's your mean. All right, the median is the middle number. So if there are 34 shoes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Between these two sevens is your median. So the median is going to be 7. Median is the middle number. All right, the mode. Mode is the most common. The most common shoe size is going to be 8. So the mode is 8. So the mean is 7.26, median is 7, mode is 8. And then the range is the highest minus the smallest. So the highest is 9 and the smallest is 6. So the range is 9 minus 6, which is 3. So mean, median, mode, and range. All right, let me clear that off. And our last one. Tara has 6 fewer DVDs than 2 times the number of DVDs that Suzanne has. So Tara has 6 fewer than 2 times the DVDs Suzanne has. So Suzanne, 2 times the number of DVDs Suzanne has minus 6 is going to be Tara's. Suzanne has 5, so 2 times 5 minus 6 is going to be 10 minus 6, which is 4. So Tara has 4 DVDs. All right, that is your ACT warm-up number 8. Thank you for watching.